Greetings, fellow stargazers, and I really mean it, because you are fellow stargazers. It's with great pleasure that I am able to talk to you, to a group of avid amateurs, because that's what I consider myself. I'm a professional avid amateur. And I always enjoy talking to people who actually do looking up, instead of people who write about it or just talk about it. I enjoy really addressing people who are actively involved in using telescopes and just the naked eye to observe the universe and all the beauty and the wonder in it. And I know that I look younger on TV than I do in person. And that's because I do my shows about 4 weeks ahead of time, so I look definitely 4 weeks older in person, and I always leave my hair at home. It does not travel well. When I got my last piece of hair in 1979, I named it Fergie. Because I felt that it had about as much business being on my head as Fergie had being in the royal family. Well, it may be just coincidence, but I was told a couple of months ago that my hairpiece was wearing out and I had to get a new one, and I said, well, Fergie's not doing too well in the royal family either. So I guess both Fergies are leaving the scene. So soon you'll see me with the new Fergie. I hope will be undetectable from the old. When I talked to Leonard Patillo on the phone a few days ago, I asked him about the kind of group I'd be speaking to this evening, and he said you were mostly the hardcore amateur astronomers, because I usually have a talk I call The Planet Named George, which is an overview of the solar system and the universe. And he said, well, maybe you can get a little bit more complicated than that. So I am going to get a little more complicated than that. I've decided to do a few different things this evening rather than my usual informal method. I'll be a little different than my usual informal method. I brought a couple of very short films to show you, so that I don't have to show you things that you already know. So we're going to see a couple very brief films first. And they're computer-generated films, and they were done many, many years ago. Can't even get hold of them anymore. I've tried to get new prints. I had all these put, as a matter of fact, on videotape some time ago for my own use in the planetarium in Miami, of which I'm the executive director. I've been there for 25 years. And these are not quite as old as that, but almost. These, I don't know if you've ever heard of them. They're called Explorations in Time, in Space and Time by M.L. Meeks. I've tried to get in touch with him, but I found out he's been dead for about 10 or 12 years, so no luck. The films I've selected, two of them to start out the show. They're about 7 minutes long. The first one I want to show you is about stellar motion. I don't know if any of you have seen these, and I don't know how much computer-generated stuff you've seen down at the Burke-Baker Planetarium, but this stuff is very, very interesting. Now, I used to when I'd show these to my friends, I'd talk a little bit beforehand and show them to them. I'd always manage to leave something out that was pertinent, that somebody might want to latch onto. And so, since you're all really into astronomy, I'm going to take the liberty of reading the introduction and the description of the film for this reason. These films were meant for college astronomy courses for astronomers, and were beginning courses, were meant to be seen several times. And after watching these films several times, there are 8 of them, students were given lists of questions, shown an introductory film, given a bunch of questions, and asked to see the film 2 or 3 more times and arrive at conclusions. In other words, discover astronomy firsthand. We don't have the luxury of doing that, but I think you're going to find these films absolutely fascinating. So what I'm going to do is I'm going to read an introduction, then I'm going to read the exact content of the film. Some of you probably won't know some of the terms. A lot of you, they'll be old stuff for you. That's how we're going to start this. We'll get a little more informal after we see the films. This is called the motions of stars. After a few years of continuous observing, it becomes quite apparent that within the span of observations, stars are fixed in positions relative to each other. This eternal aspect of stellar positions influenced earlier ideas about the immutability of the heavenly realm. We'll be talking about that a lot later. The stars, in fact, are not affixed to positions in space, but move relative to each other as they generally circulate about the galaxy. These motions in space, which include the sun's motion, result in changes in the relative positions of stars as seen from our Earth. From year to year, the magnitude of such positional variations is small. But over the span of centuries, the changes accumulate and redraw the constellation figures. From the observed motions of stars, astronomers have been able to determine the direction and the velocity of the sun through space relative to nearby stars. Superimposed on the actual motions of stars is the reflection of the Earth's annual motion about the sun. Because the effect of the Earth's motion is greatest for the closest stars, I'm sure you know what we're talking about here, its observation provides a direct measure of a star's distance from the sun. We all know what that is, don't we? Heliocentric parallax, okay. In this film, we inspect the motions of stars which result from the combination of the motions of the Earth and of the sun and of the stars. So we're going to look at different motions with respect to different items in space. The Earth, sun, and stars. This is the summary of the film. Watch it very carefully. You're going to find this fascinating, and it goes by so quickly. It's kind of mind-blowing. I've seen this thing about, I don't know, 50 times, and I still just kind of mind-boggle because it's really so lovely and so exquisite. This first film shows the Big Dipper, a part of the constellation Ursa Major, and even fainter stars are added, down to 8th magnitude. Those visible through a small telescope, you should know that. The positions of the stars in the Big Dipper shift back to about 3000 BC. How big a change will that make? You'll see. Not much. And alternate with their present positions. Now this change is small, but by speeding up time, the stars will move to where their positions will be 100,000 years from now. The large changes erases the familiar constellations, the configuration of the Big Dipper, and these changes, which we're going to see, are caused by the star's proper motion. That is their motion in space with respect to the sun. We'll have no sun motion involved in this first segment. The scene then shifts to the bright star Vega and the constellation Lyra the Harp. We zoom in on Vega so that we can see its motion and note an annual wiggle in addition to its proper motion. This annual motion is not due to any actual motion by Vega, but rather to the Earth's revolution about the sun. The effect is called heliocentric parallax and proves the validity of the Copernican system. We next move to Taurus and focus on Aldebaran with the same magnification that we use for Vega. Both Aldebaran's proper motion and parallax are smaller than those for Vega, indicating that Aldebaran is farther from the sun than Vega. You'll see this demonstrated. Then we dissolve the star field of Hercules and Lyra and mark the direction in space towards which the sun is moving. Now this is fun. How many of you come from up north? Way up north where it snows a lot. Okay. Well, you know, I was raised in Wisconsin in the wintertime. In a snowstorm, you know, if you drive through a snowstorm, everything seems to come from a radiant point on your windshield, and the snowflakes, and they seem to be coming from a radiant point just like a meteor shower theoretically. And the things seem to be going very fast. You have a real sense of direction and motion forward. If you look out the side windows, even though the snow is moving the same velocity relative to the car, it doesn't look as dramatic. If you look out the back window, if you had lights on, or it's in the daytime, it looks as if all the snowflakes are converging into a single point. Well, this is the same with the stars. Okay, so he's dissolved to a star field at Hercules and Lyra. I haven't had dinner either. Good Coca-Cola. Bad digestion, huh? Okay, we then dissolve the star field at Hercules and Lyra and mark the direction in space towards which the sun is moving. This point is called the what of the sun's way. Anybody remember that? It's kind of a lovely phrase. I've always thought it's quite poetic. The apex of the sun's way. So we're going to go out in space as if we're moving with the sun out in space. We advance in time 200,000 years and watch the stars drift away from the apex. Watch closely for the sensation of motion away from the apex. We then switch our view to the constellation Andromeda and Triangulum. Now, some of you, I imagine, are imagining the celestial spheres. We're talking about these constellations, the relative positions. We then switch our view to the constellations Andromeda and Triangulum, which lie to the side of the sun's motion, like the side of the car. Then we again advance by 200,000 years, and we see the stars drift by, but with no convergent point whatsoever. They just drift by. Finally, we look at the antipix and apex of the sun's motion, the direction from which the sun is moving, and stepping into the future, we see the stars converge on the path which the sun has left in its wake. So like looking out the back of a boat, you're seeing the stars in the wake of the sun's way. And then there are all kinds of test questions afterwards. Okay, we should get on with our first 7-minute film, The Motions of Stars. Everything is computer generated. Can everybody see the screen from here?
In ancient times, astronomers divided the stars into 6 classes according to brightness. The brightest stars were classified as first magnitude, the next painted second magnitude, and so on. Here we see stars of fourth magnitude and brighter. Now we've added the 5th magnitude and the 6th magnitude. This is the region of the Big Dipper, when all the stars commonly visible to the naked eye. But with a small telescope, you can see 7th magnitude, 8th magnitude, and perhaps even fainter stars depending on the size of the telescope. Although we are not aware of it, the stars are moving, and the pattern of stars changes continually. Let's see how these stars appeared to people very long ago. First, we'll mark the positions of the Dipper stars in 1975, and then shift them to positions back in 3000 BC. The positions have changed only very slightly since civilization began. So the constellations of ancient Egypt are virtually the constellations we see today. But let's watch the motion of these stars over a much longer period, say 100,000 years. The pattern of the Dipper is lost over 100,000 years. Now let's move back to the present time. This is called proper motion. All stars, including our sun, are moving through space with various speeds in various directions. The stars nearer the sun appear to move more rapidly than the distant ones. We'll see how astronomers can measure proper motion and the distance to the nearer stars in other parts of the sky. Here in the constellation of Lyra, the Harp, is the bright star Alpha. It's also called Vega. We'll look at Vega with a magnification of 30,000. With this much magnification, we should be able to see the proper motion in a relatively short time. Let's start in 1975. Our time rate is 5 seconds per year. This seems more complicated than proper motion alone. In order to understand what we're seeing here, let's mark the point with the proper motion of Vega. The star appears to orbit around this point, revolving exactly once a year. This motion around the green mark is an illusion caused by the Earth's revolution around the sun. The effect is called parallax. If we could observe Vega from the sun, it would appear always at the center of the gate mark, moving with the proper motion. The parallax confirms that the Earth moves around the sun. The length of this line represents 1 second apart. So the angles involved are very small and must be measured with great care. But once the parallax has been measured, we can find the distance to the star using simple geometry. Vega turns out to be 25 light years away. Let's look at the motion of another star for comparison. Here, in a group of stars called the Hyades, recognized by their V-shaped pattern in the sky, is the star Aldebaran. We're going to magnify Aldebaran 30,000 times as we did Vega. Again, we start with 1975 and set our time rate at 5 seconds per year. Aldebaran has less proper motion than Vega. The green mark moves with proper motion alone. The parallax is smaller, and the star appears to move back and forth on a line. The appearance of parallax depends on the star's location in the sky with respect to the plane of the Earth's orbit. Aldebaran lies almost in this plane, while Vega lies in a direction more nearly perpendicular to it. The parallax indicates that Aldebaran is 65 light years away, about 2.5 times further than Vega. Let's watch the motions of stars in some particular directions. Here we see stars down to 8th magnitude. The region includes the constellations of Lyra and Hercules, upside down from this angle. The green cross marks the point in the sky toward which the sun is moving. Let's watch the proper motion of these stars looking straight ahead as we go forward in time 200,000 years. Now from 200,000 AD back to the present. Enormously speeded up motion, we drifted with the sun into this cloud of stars and then backward. The proper motion tells us which direction the sun is moving. If we move sideways perpendicular to the sun's motion, we can see the constellations of Andromeda and Triangulum. Again, we'll move 200,000 years into the future. Each star has its own particular velocity as the sun glides through space. Now let's look backward as if out of a rear window. This is the star pattern of 100,000 years ago. From these unique vantage points, and moving thousands of years through time, we can see the effects of two quite different kinds of motion. The Earth revolves around the sun, producing parallax, and the sun drifts through the stars that surround it.
Well, you know, you really can see down to 8th magnitude in these films, but of course with the indoor light pollution, I only got down to about 5th. And of course the yellow lights, you know, they change the background. You notice how they change the black background to an orange background? That really is a black film. So now you know what these wonderful lights do to your telescopic observations, right? Living proof right here and now. Oh, may I have some more lights, please? How'd you like that?
Good. Is that the music from Forbidden Planet?
I don't know where that's from. I really don't. But did you, but it's the old stuff before the synthesizers really got going, you know, where they really got cranked up. Somebody gave me a copy of Forbidden Planet, incidentally, for Christmas. And I couldn't believe how antique that music sounded. It was maybe a really primitive instrument. Very, very interesting, but really quite limited in scope as electronically concerned. Did you learn anything from that? Demonstrate a few things you know you observe in the field, you know, but you don't really visualize. Sometimes it's hard to visualize. Well, I got another one that you're going to love. You're all going to love, especially, you know, all those of you who do telescopic observation in the wintertime. This is another short film just like that, and then we're going to go on to something entirely different. Yes, sir?
Do you know if it exhibited or if it calculated for that same parallax motion in all of the stars that it was showing, or just the one that was targeted?
Good question. I don't have the answer. I don't have the answer to that. I think that probably parallax with most of those stars, heliocentric parallax would have been so small. You know, when you go up past 100 light years or 150 light years, 300 light years max. Is 300 light years the max for heliocentric parallax? I think it's 300 light years. So when you get further out there with all those stars, it's not going to make any difference. I wish these films were still around, because I wish that astronomy clubs would get hold of films like this, and they're just impossible. Just impossible to get hold of these things. But this one you're going to love. I selected these two especially for you because those of you who do telescopic observations, at least when you first start telescopic observations, I know you all are interested in this. Sirius and the white dwarf. Right? Right. Binary star systems. One of my favorite topics. I'm just glad our star system isn't one of them. Weather is complicated enough in Florida at this time. Binary star systems are important to the astrophysicists because an analysis of their motions is the only direct method of measuring stellar masses. In 1862, the American telescope maker Alvin Clark. Have you got any Clarks in the club? Huh? You don't have any Clarks in the club? Oh, shame on you. We used to have 5 in Miami. I think they all got stolen. I thought maybe one of you maybe had one here. I'm still trying to track them down. In 1862, the American telescope maker Alvin Clark identified Sirius B, a faint companion to Sirius. From the observed motions about the barycenter of the system and the application of a generalization of Kepler's third law, the mass of Sirius B is found to be about the mass of the Sun, about 2 times 10 to the 33rd grams. Although it has approximately the same mass as the Sun, Sirius B is much hotter than the Sun. It appears white rather than yellow in color. Yet it is far less luminous, about 1/1000th the Sun's luminosity, than would be expected from its high temperature. Because of the lower luminosity but the higher temperature, Sirius B must have a much smaller diameter than the Sun. Recent calculations indicate that the star is only 8 times 10 to the minus third the Sun's radius. With the same mass as the Sun, but a much smaller size, the density of Sirius B is enormous, about 3 times 10 to the 6th power grams over centimeters to the third. 1 pint of Sirius B would weigh over 1,000 tons on Earth. In this film, we demonstrate the motions of the Sirius system which led to the discovery of this first white dwarf. The film is very simple, very straightforward, but very dramatic. I can't decide. This is my favorite, or the last one's my favorite. But these two are my favorites. The film opens with the constellations of Orion and Canis Major with stars brighter than a magnitude of 6.5. However, in here we'll probably see down to 5th magnitude, right? Because of light pollution. The camera zooms in on Sirius until the star's proper motion and the barycenter are visible. Sirius weaves a wavy line in the sky instead of a straight line because of its motion about the center of mass with its companion. Note, the effect of parallax has not been included in this sequence. That answer, because that's so close. The barycenter appears, and the camera zooms again until the companion is also visible. The orbital plane is tilted from its normal inclination as seen by an observer on Earth until it is viewed face on. The orbits are now seen in their true perspective, and the actual distances of the stars from the barycenter is clearly seen. The camera zooms in on the two stars and shows their relative sizes as a visual introduction to a description of the physical nature of white dwarf stars. The camera finally zooms back to show the entire constellation of Canis Major. Who knows what a barycenter is? Anybody remember? Okay.
The center of mass of the system.
Right, center mass of the system. Here is the center mass of any two connected bodies. The connection may be physical, such as a solid rod, or gravitational, such as that between the Earth and the Moon. Anybody know where the barycenter of the Earth-Moon system is?
Beneath the Earth's surface.
Yep, about how far? About how far? It's about 1,000 miles, isn't it? I think about 1,000 miles. I think I remember that right. Okay. It is the balance point of the system, such as the fulcrum of a seesaw. Alrighty, this is a very brief film. I think you're going to really like this one. Get ready. That's on the film.
On a clear, dark night between November and March, you can see these stars from almost anywhere in the world. On the right is the constellation of Orion, the mighty hunter in Greek mythology. Beside the figure of Orion in the sky is Sirius, the brightest star in the heavens. Sirius is 8.7 light years away, a neighbor of the Sun. Only 6 stars are closer. It lies in the constellation of the Great Dog, Canis Major. Sirius is Alpha of the Great Dog. Other bright stars in this constellation are also labeled with Greek letters. Sirius is also called Alpha Canis Majoris. We're going to look at Sirius with very high magnification. Our time rate is speeded up so that 5 years pass every second. Because Sirius is relatively near, it appears to move against the background of much more distant stars. This is what astronomers call the proper motion. But instead of moving along a straight line, as we would expect, Sirius leaves a slightly wavy trail. The wavy motion tells us Sirius is orbiting about another star that is too faint to see. In other words, Sirius is one component of a binary system. Let's take a closer look at this. Let's mark the imaginary point around which Sirius appears to move. Sirius makes a complete revolution every 50 years, or on our time scale, every 10 seconds. But if Sirius is one component of a binary system, where is its companion? Well, if the imaginary point is the barycenter of a binary system, then the companion must lie somewhere along this line. Of course, the companion must be on the opposite side of the barycenter, the exact position depending on the relative masses of the primary and the companion. The companion must be very faint, perhaps not shining at all. Let's move still closer. Here at last is the companion of Sirius. The barycenter is clearly not a focus of the elliptical orbit, so we must be viewing the orbital plane of an angle. We calculate from the position of the barycenter that the companion has a mass that is 42%, nearly half, the mass of Sirius. Since the distance to Sirius is known, astronomers can calculate the size of these orbits and the masses of the individual stars. The mass of Sirius turns out to be about 2.5 times that of the Sun. The mass of the companion is about equal to the mass of the Sun. We'll take a closer look at both of these stars. We're now close enough to see the disk of Sirius. And here's the size of the Sun for comparison. But the companion is still just a point of light, even though it has the mass of the Sun. At last, we're close enough to see the disk of the companion. It's as small as the Earth, a kind of star astronomers call a white dwarf. Matter in this star is squeezed so tightly by the inward pull of gravity that even the electron shells of the atoms have been crushed. A cubic inch of this material has a mass of several tons. As queer as these stars seem, they're common. About 3% of the stars in our galaxy are white dwarfs. Some, perhaps all, are remnants of exploding stars. Whatever their origin, white dwarfs are dying stars. Their supply of nuclear fuel is exhausted. They're slowly cooling and will become red and finally black dwarfs, stars that no longer shine. Sirius gives us just one example of how peculiar star types may be discovered and studied in binary systems.
How many of you have seen Sirius B in the telescope? I just love that film. I think it's just wonderful. Imagine these things were produced 20 years ago in 1973. And the incredible thing is you can't buy them anywhere. As a matter of fact, Houghton Mifflin didn't even have any records of the things. We tried to track it down through the Smithsonian, and just nobody has any comprehension that these things existed. And I got them just by chance 20 years ago, looking through some magazine. I happened to notice a little tiny ad and sent away for one of them and was so enthralled by it, I bought the whole set for the planetarium, and we've had them ever since. I think they're the kind of things that would enhance high school and college astronomy classes and amateur astronomy groups. You know, to take one of these and show it, discuss it, use it for testing, for talking, for calculating. Really a lot of fun. I usually don't do things like this for clubs. Since I usually have a much looser, simpler lecture. Okay. Now we're going to go into something entirely different. We're going to go to slides. Pictures that don't move. I'll do the moving. I'm sure that all of you have seen an aster, right? An aster, a flower. Does anybody know why it's called an aster, not a chrysanthemum or not a rose, or anybody have any idea?
Star-shaped petals.
Very good. Star-shaped petals, an aster. You know why we call that little funny mark on a typewriter an asterisk? Anybody want to venture a guess, or a typist here?
It's star-shaped.
Star-shaped, okay. Does anybody know where the word aster came from? Aster came from, aster is Latin, an ancient Roman word for star, and it came from the Greek, astron. So, astronomy, the study of stars. Astrology, well, I've often been asked what's the difference between an astronomer and an astrologer. My first answer is usually, well, astrologers make a lot more money. But we have, if we can do something tonight a little bit unusual, you know, things are never as they seem. And we have kind of gone into the future and used actually high-tech, low-tech from the 70s to demonstrate what we know about the stars and what the stars will do in the future. So we're in a kind of unique position because each of you, or most of you, own telescopes that Isaac Newton and Galileo couldn't possibly even imagine the quality of the eyepieces and the mirrors and the images. I'd like to do something a little different. You know, I usually do this with, I used to do it a long time when we used to lecture to school kids. In the planetarium, I'd ask them to sit and hold their breaths, then I'd leave, you know. And, I'm not that good with kids. I'd ask them to sit as still as they possibly could in their chairs, and then I'd say, you know, things are not as they possibly appear, because as you sit in your chair absolutely still, it is hard to believe that you're moving at a speed of over 66,000 miles an hour in the Earth's orbit around the sun, and you couple this with all the motions throughout the galaxy and the galaxies throughout the universe, we come up with dizzying numbers. Guy Atwell, I think, once a year prints the combination of motions and their speeds. It's quite complex, but we know about these things intellectually, but we don't feel them, and they certainly don't ever come up in much conversation, unless a time like this. Well, I would like to do some time travel and kind of go back in time to the premise of the first film, and that is, if you remember the very first sentence from the first film, that is that all the stars seem immutable, all the stars seem unchanging, and basically, when we looked at the Big Dipper 3,000 years ago, or if we went back 5,000 years ago, they'd look the same. The Egyptians, the Romans, the Greeks, all the ancient civilizations that we know that in recorded history, in historical time, have all seen the star patterns basically the way we have. Not much of a change. A few minor changes that some astronomers would know, but not an awful lot. And so we have to kind of, I think, in order to understand what I want you to understand tonight, what I want you to leave with and walk away with, is a basic understanding of how people related to the stars before the 20th century. Because they related to the stars much differently than people do today. We see the stars pretty much as a low-tech or high-tech hobby, a branch of science that we're interested in, something to do. Probably the things that you do with your telescopes are things that people were incapable of doing 200 years ago at all, even with the best telescopes. Well, we don't see the stars at all the way people saw them years ago, because number one, we do have lots of light pollution, lots of air pollution, but we don't see them from the same standpoint because we don't see them with a certain kind of naivete, in the historical sense. But if you go back in time, everything that people saw in the sky was called a star. Everything was called a star. Now, when people looked up the stars, they put their history in the stars. They'd take their children out at night before anybody invented writing, when there was only verbal communication, only word-of-mouth communication. And people like us wanted their family heritage, their ethnic heritage, their particular portion of civilization heritage, whatever their tribal heritage was, be passed on to their children and on to their grandchildren, etc. And since they had no written words, even before the invention of pictographs, they had a way of preserving their history by oral history, oral tradition, by talking. And people were pretty good at this and very, very factual. And a lot of our myths, our legends that we read about in books were passed down for hundreds and thousands of years before anybody ever wrote them down. And basically when people would go out under the night sky with their kids hundreds of thousands of years ago, they'd look up at the stars, and many of the stars would seem to form logical patterns. And depending on what civilization was looking, they followed patterns that were important to their social systems. The Egyptians saw hippopotamus, they saw crocodiles. Some civilizations seem to see the same things, and most civilizations always saw a giant figure of a male in Orion. Most people saw a scorpion, and the scorpion, except for like the Hawaiians, the Polynesians saw a giant fishhook out of which the Hawaiian Islands are raised out of the ocean. But a lot of the things were similar, mostly dissimilar. I like the American Indian legends most of all because they seem to be very poetic, and probably because I was raised with Greek and Roman legends, and so anything that's a little bit different is a little interesting. Well, people would take their kids out, look at the shaped stars and say, well, this looks like a bear, or this looks like a male figure or a female figure. So when you look at these stars, when you take your children out under the heavens, I want you to tell them this story. Perhaps the story was about a local hero, a hero of the tribe, a great epic battle, or it might be a moral lesson. Most moral lessons were passed on. A lot of nature lessons, you know, why the leaves turn gold and red in the fall, you know, the explanations why there were deserts, why there were hot areas of the earth, and why there were cold regions of the earth were all explained through stories about the stars. Well, we can, in a way, call the stars the oldest and largest library of human folklore and wisdom on this earth. And I'm sure that if there's intelligent life on other planets and other solar systems, they undoubtedly, all civilizations go through the same kind of a period where you use the most permanent things to preserve your records. This is not a stupid idea, it's very smart. If the stars seem to be the same for hundreds of years, and somebody who is 90 years old says, well, it looks just the same way as I did when I was a kid, that's the thing that they're going to use to try to keep a permanent record through oral tradition. So everything was a star. They observed that stars didn't change for hundreds of years. They kept records. When they started keeping records in China, they noticed the pattern stayed the same. The Egyptians noticed the pattern stayed the same. So these stars had great importance. They had great permanence, great value. There were some stars that did change nightly, besides, of course, the normal rising and setting of the stars. And they were called stars, but they were just simply called a different kind of a star. They were called planetas, which we still use the word today as planets. It's the Greeks call them planetas. That's the word we happen to use, planets. For the stars, the so-called stars that move among the fixed stars. We know, of course, we call them planets. We know that they're not stars, but they appear star-like. And if you go out and look at them and nobody knows it's a star from a planet, they'll say, oh, look at that beautiful bright star. We still call Venus the evening star, the morning star, Mercury evening, morning stars. Not much different. We hang on to some of the old traditions. Well, if we want to really identify with the past and see how important the heavens were in the past and therefore to us, ultimately, we have to kind of think like these people. They called, the Greeks called a certain kind of a star that bewildered them and puzzled them by names that many civilizations called them. There were certain kinds of stars called evil stars. Remember that word aster? Star? What do you think a disaster is? An evil star. Means evil. Disaster, evil star. Disasters are evil stars. Well, the Greeks called these evil stars the stars which appeared suddenly and magically and mysteriously out of nowhere and grew in size and shape, and their movements could not be predicted. And they grew longer and longer and brighter, and they did strange things in the heavens, and they totally freaked out entire populations all around the world. They still do, as a matter of fact. The Greeks called them astron cometas, and the Romans called them aster cometas. And today, we call them comets. Astron means star, aster means star. Cometas, cometas means long-haired. Long-haired stars. Disaster, long-haired stars. Homer in the Iliad said long ago in oral tradition that from these long-haired stars rains down pestilence, disease, and war. And today, we avidly study these cometas, these comets, simply a word for long-haired stars, with a great deal of gusto and excitement. But we are probably the first generation to ever really understand, and certainly the first ever to see, comets close up. We indeed have. Well, we tend to think today that these things are only important to a limited number of people like us. That wasn't the truth a long time ago. For instance, I would like to show you some lovely astron cometas, some disasters. If we can, oh, I got the slide machine here. Well, amazing. Now, if this makes noise, we're in trouble. Uh-oh, the light's been on. Here we go. Let me focus this if I can here. Okay, I'm going to show you some lovely disasters. Some lovely astron cometas. You must remember now that if you're living 2,000, 3,000 years ago, and you know nothing about the nature of the universe, you have no idea what the sun is, what the moon is. Remember, people didn't see the moon close up until Galileo, had his little funny telescope, his little tube, his optic tube back in 1610. And so people really had no way of knowing what was going on. And they were really spooked. Well, if you saw these things coming at you, and each comet maybe behaved differently, and you had clear, dark skies all the time, these could become pretty frightening, because people thought that all the stars were divine, were gods and goddesses. Many civilizations named them as gods and goddesses. They thought these stars were divine. Don't laugh. Astrology, you'll find astrology columns in every single newspaper in America today. You talk about truth in advertising. I mean, astrology is the world's oldest religion, and it's a hangover from all this disaster stuff. The ancient Babylonians, one Babylonian column about 1100 BC, states that about these disaster stars, said that these stars, these dangerous, evil stars, are like scorpions. You can even see the stinger in their tail as they cross across the sky. Show you a few more lovely disasters. Of course, by
that you just showed us?
No. I can't remember what that was. I was trying to ask. It was a comet about 10, 15 years ago. I can't remember which one it was. This is an old drawing of Halley's back in the 17th century. The comet of 1812, which I'll be talking about a little bit. Well, I'll just tell you about this. I'll tell you right now. This was one of the comets. One of the comets that Napoleon used as one of his symbols. He said the star, and this is a French woodcut, he said that the star on the Pont Neuf, I believe, he said that the star was a portent of his ability to war. It was a good star for him. And then another comet came in 1813. He used that also as a reason to go to war. And of course, he claimed that when he was born, that there was also a comet visible. And people wrote that when he died on the Isle of Elba, that a red comet appeared the night that he died. That's probably the last time in history that we see comets used to follow and trace a career of a politician or a general. Except for Ronald Reagan and his wife, Nancy. This is over Württemberg. I think this is the 17th century also, a drawing. Lovely comets. Of course, remember they had dark. This is over Paris. That was a Halley's Comet, I believe, from the last century, when Mark Twain was born. This is Comet Kohoutek. How many of you saw Comet Kohoutek? Okay, how many of you saw it? Well, good. Okay, I did. I was very fortunate. In Miami, I knew enough not to go out in December of that year, December 72, I believe it was. When Kohoutek was on its way in, I remember Kohoutek himself was out on a ship on the Queen, on the QE2, in the North Atlantic. He was convinced by the people, the Cunard, the QE2, to take the ship out for a comet watching. And of course, if any of you ever been in the North Atlantic in December, Comet Kohoutek didn't even want to be interviewed on the radio, I remember at the time, because I was with a radio station with Lynn Russell from CNN then. We were doing a radio show together. I was doing a version of Star Hustler, a daily version of it, which made me age. That's why I lost my hair. And I remember Kohoutek didn't even want to come to the ship-to-shore radio because he was so upset, because he knew better than to get on that ship in the Atlantic in December. He blamed it on meteorologists, but we knew he... Well, after Kohoutek went around the sun and started going back out, I had a $99 Comet Kohoutek 3-day trip to one of the Bahamian Islands on an Italian ship called the Flavia on the Costa Lines. For 99 bucks, we went out for 2 nights and 3 days, and we got out less than 5 miles away from Miami, and Kohoutek was absolutely like a floodlight going from the horizon up almost 3/4 of the way up the sky. It was absolutely fabulous. The captain was so absolutely overwhelmed by it that he called dinner off and had everybody go out on deck, including all of the chorus girls from London, out in their little net stockings. And it was a January night. I remember they were very cold.
Near Miami?
Oh, in January. Oh, yeah. At night, on the ocean, not on the ocean, 5 miles out. That's good old Kohoutek. Bennett. Beautiful, beautiful shot. And Comet West. I actually saw Comet West break up in 1976. You heard that old line, how to get a comet to break up, you know, tell it some good astronomical jokes, you know. That's a bad astronomical joke. So we have kind of a history of comets and ancient man. As a matter of fact, few people realize that our whole Western civilization is based upon one comet that really doesn't have a proper name, Comet of 44 BC. I'm going to tell you a story that I spent about 20 years researching. And I'm going to show you some interesting stuff, some really fascinating stuff. I'm giving you some comet quickies. Comets were extremely important in history. Most world leaders back 21, 22, 2,300 years ago, 24, 2,500 years ago, all had court astrologer, astronomers, and they used these people to help them predict when to go to war, when to do things, when not to do things. And it was very fashionable and almost necessary after a while that many rulers in many countries had to have a comet sighted when they were born. If a comet appeared in the sky, because these were disorders of an otherwise orderly universe, because the planet's motions could be predicted by astronomers, comets could not be, were the only things that could not be. These were seen as disorders in an orderly universe, as direct warnings from the divine stars, from the divine asters. They were seen as direct warnings to mankind. Well, what was one man's disaster frequently turned out to be another man's fortune, depending on which side you were on war. But for the most part, comets were seen as portents of impending doom. And comets were used as really political tools in incredible ways. Genghis Khan, it was 1222, I believe it was, A.D. Genghis Khan slaughtered over 1 million people. I think it was 1222. Slaughtered over 1 million people when Halley's Comet appeared because he said it was his comet. He claimed he was born under a comet. Muhammad was said to have been born when a comet appeared. So, we're going to take a look at how one evil star, how one comet changed history forever, and is probably responsible for the very Western system, political, intellectual, and spiritual, under which we exist today. This is a picture of a young lady that was painted in around 1630 by Guido Cognacci, an Italian painting. Anybody want to guess who this lady is? I think I heard somebody say it correctly. Cleopatra. Cleopatra the 7th. How can we tell? Well, here's the asp biting her. This is one of the ways we've pictured Cleopatra the 7th. There are many Cleopatras. She was the most famous, and the last one. She had a daughter named Cleopatra. And she was Cleopatra the 8th, but she really didn't rule Egypt. As a matter of fact, Cleopatra had 2 children by Mark Antony. One was named Alexander because she was a Ptolemy. She was actually Greek. She had 2 children. One was named Alexander. They're twins, and one was named Cleopatra. Cleopatra means glory of the Father. And Cleopatra, I'm going to sit down here because I like to sit when I talk sometimes. I always stand when I talk on my show. I stand on those moonbeams and I get dizzy. Cleopatra, her 2 children, Alexander and Cleopatra, but they had second names which became their first names. Alexander Helios, which is in Greek, the sun, and Cleopatra Selene, which is the moon. These weren't done just for kicks like the hippies in the 60s, like, you know, moon, whatever. These were done with real import. These were only the royalty could name their children after heavenly objects. Well,
Is that a snake biting her?
sure is.
I mean, they put her to death?
No, she put herself to death. She committed suicide.
Not with all those people around her.
No, I hope not. There were only 2 according to all accounts. Now, we really don't know exactly what she looked like, but we've come pretty close to what she looked like.
Cleopatra of Antony?
No, I'll answer your questions after the lecture, okay? This is not exactly what she looked like, but we get an idea of how the people who ruled Egypt looked at that time. This is a picture of Arsinoe II, who was one of the queens of Egypt around 270 BC. At that time we see wonderful Egyptian hairdos. You see great beauty in this woman. She was a predecessor of Cleopatra the 7th, the one that we remember. We think of Cleopatra like this. This is Cleopatra and her son Caesarion, Ptolemy the 15th. Cleopatra and her son. Now this carving is on the Temple of Hathor, which is now called at Dendera. Anybody here know what Dendera is famous for? Back there, Dendera. Would that a yawn or a scratch your head, or you wanted to say yes? Dendera, Egypt. What famous astronomical thing is on the ceiling of the Temple of Dendera? It's a gigantic portrayal of the Egyptian heavens with all the constellations, the only one we have. Well, on the front of this is Cleopatra, the 7th, and her son, Caesarion. That should ring a bell. Little Caesar. The son of Caesar. She had a son by Julius Caesar. Okay. This was long thought to be a portrait of Cleopatra, but we're not quite sure. But I'd like you to notice the hairdo and what we call the diadem. There's a band around her head, which we call a diadem. Alexander the Great had one of the, we still call certain kind of tiaras diadems. Men and women wore diadems if they were royal. It was a band, similar to a sweatband today. As a matter of fact, you know, royalty wears it. I mean, how many times have we seen Hillary Clinton wearing her sweatband, right? Well, this is kind of an ancient form of Hillary with short hair. Anyway, Cleopatra was a trendsetter. She wore her hair in kind of a, she always used the diadem. It was made out of metal, tied in the back. They usually had loose curls around the sides of their face in her time period. It was the fashion at that time for a long time. I say a long time. She didn't live very long. She died at the age of 39. But this may have been a portrait of her. It may not have been. We know that she, of course, was, like all of her ancestors, was a Ptolemy. She was Greek. She was not Egyptian. None of the Ptolemies who ruled Egypt, the pharaohs and the queens in Egypt from about the time of Alexander the Great on, were Egyptian. They were Greeks, Alexandrian Greeks. In Alexandria, they're Hellenized. Greek society and Egyptian society blended. She was a brilliant woman, if she may not have been beautiful. She spoke at least 11 languages fluently, and they say she was the greatest stateswoman probably of all time. We don't learn about her in school because her system failed and ours won. The Western civilization, the Roman civilization won. We learn more about Roman government and Roman history than we do about Egyptian history. Actually, we came very close to following what we call the Alexandrian, the Eastern Hellenized tradition, rather than her. If it hadn't been for a comet, the world would have been different. We know that this is a coin, and we know that she did look like this when she was 22, when she went to Rome to visit Julius Caesar. 22 years old, and she's not unpretty. She has a prominent nose, but she's not unpretty, and this is I think this is a very good portrait of her. She had a Greek nose. They said she was absolutely charming, and she could talk politics and literature and music better than any man, any leader, any world leader, and her palace was the center of culture. Her palace was the real center of culture, like perhaps New York was the center of American culture 30 years ago. Perhaps like Paris was the center of culture in the 20s. Alexander was the center of learning. Of all the intelligentsia lived in Alexandria, Egypt. And her palaces, her entertainments, she was notorious for her, famous I should say, for her palaces, for her philosophers, for her mathematicians, for her astronomers. When Julius Caesar changed the calendar, he relied upon Sosigenes, one of her royal astronomers, to construct the calendar. The smartest people in the world lived in Alexandria at the time of Cleopatra, and we're talking the last 50 years BC. Well, Cleopatra met Julius Caesar. Julius Caesar was much older than she was. And he was the most powerful man in Rome. She had a dispute with one of her brothers who she was married to. They did a lot of that back then in order to consolidate the money within a dynasty. And Julius Caesar was the greatest general of his time. He went to Egypt and he became enamored of Cleopatra in Egypt. He knew that he was very wealthy, had him in many campaigns, war campaigns, acquired great amounts of wealth. He was getting much power, and he was determined that he was going to become the sole power of the Roman Empire. He expanded the empire. He was going to be the man who ruled it. And he got a lot of encouragement from Cleopatra. She wanted to be the sole power in Egypt, not have to worry about any trouble with her brothers and her sisters. And he made sure, because he made sure they were executed or else died in wars that he was responsible for. He fell in love with her, although he was married. But they bent the laws the way we do today. And he was married according to Roman law, but not according to Egyptian law, so he married her under Egyptian law, which made it legal in Egypt and not legal in Rome. And in Rome, her marriage wasn't recognized because Egyptian, you know, that kind of thing. If you got good lawyers, if you got a lot of money, you can find good lawyers no matter how old the civilization is. Well, this is considered to be perhaps the only real honest life portrait of Julius Caesar. This is done probably when he was around 54, 55 years old. All of the Egyptians who ruled considered themselves divine, divinities. Remember, the stars were considered divine by all peoples. Cleopatra could trace her divinity back to Isis. Julius Caesar liked this whole idea about divinity, and he traced his divinity back to Apollo and back to Venus. It was a strange kind of a thing that we can't kind of imagine today, but these kind of shenanigans went on regularly. And make a long story short, Caesar had a lot of fights with the Senate. He really destroyed the Republic of Rome, and he took over and he became a dictator. He became the dictator of Rome, but he also, before he died, had a statue of him placed in a temple, probably at Cleopatra's request, in a temple where people worshiped so that he could be worshipped. This didn't sit well with the Roman senators, the nobility, and he really didn't care much. He did it anyway. So he was assassinated. Assassinated because the Roman people simply couldn't tolerate a person who made himself dictator for life. That's what he made himself, and he virtually ruled all of Rome. He was assassinated on the Ides of March, the 15th of March in 44 BC. And he left a will, there's a lot of dispute about these wills, but he left a will naming his nephew, Octavian. This is a portrait of Octavian as a young man. Octavian left a will saying that Octavian would inherit his wealth. Now, Caesar was really filthy rich. I mean, would have put Donald Trump and all the wealthiest people in America and Europe today together, and you'd be getting a start on how much money these people really had. They owned lots and lots of stuff. They owned countries, and all the money's in it. These people were not small fry when it came to hoarding wealth. Well, Octavian was quite young, 18 years old at this time, and he had kind of bad health. And in the will, it said that if Caesar had no heir from himself, a son or a daughter, that Octavian would be his heir. We kind of think that Octavian doctored the will. We don't know. There's been a dispute about this, like the disputes about Shakespeare, who he really was. But the upstart is that the will had his estates from Julius Caesar going to Octavian. And of course, before Julius died, he adopted in his will Octavian as his legal son. So his name became Julius Caesar Octavian. Julius Caesar Octavian. A good name to have with all that money. Well, Cleopatra didn't like this very much because she had a child by Caesar, and she named him Caesarion, and he should have been the legal heir according to Cleopatra. But Cleopatra had no support in Rome. They didn't want to have anything to do with an Egyptian, with a Greek-Egyptian queen. All they wanted was her green. That's all they wanted. They didn't want to have anything to do with her. Well, Octavian, I put this picture, I thought you'd like to see what his sister looked like. Octavian's sister was named Octavia. This is a cameo. Wonderful portraits. These portraits are over 2,000 years old. Look at the family resemblance. Octavian and his sister, Octavia. Octavia is interesting. Look at her hair, her hairdo. You know, it's the chignon, the kind of the same kind of style as Cleopatra had. A very popular hairdo at this time, without the diadem, of course, because she wasn't royalty. Octavia married Mark Antony. But she married Mark Antony, according to Roman law, after Mark Antony had 2 children by Cleopatra. Alexander Helios and Cleopatra Selene. Well, Here we see a very, we see that, you know, not all coin and portraitures are very good. This is a very famous coin. It was a coin issued when Cleopatra and Mark Antony became the most powerful force outside of Rome. Mark Antony, after Julius Caesar died, went to Egypt, and after some time fell in love with Cleopatra. These are rather bad portraits. As a matter of fact, I had a similar portrait of a coin of Octavia, and she looks just about like that. So they could be very beautiful or not so well done, and of course nobody looks like that. That's Mark Antony and Cleopatra, and here she's about, oh, I'd say about 36 years old. Doesn't have much time left. But at this point, Mark Antony had given her many Roman lands, and these two people together, the inscription on this coin says, Queen of Kings, Cleopatra, Queen of Kings, and of men who are kings. And no, forget what the rest of it says. Queen of Kings. What it meant was that this was a Roman coin with Latin inscription produced by Mark Antony. People minted their own monies back then if they had enough money. It was a silver denarius. This was circulated all through Rome. You see, when you had enough money, you had your own mint. And you'd pay people, pay armies. Caesar paid his armies with his own mints. That's the way he got them to cross the Rubicon. He minted his own money and paid them. Monies were used for several things. Today we have television, we have commercials. We see commercials all the time and they work. We buy. This was the equivalent of a TV commercial. This was propaganda. Coins were the only real propaganda in the ancient world. Most people didn't know how to read. People were illiterate. They didn't have radio, didn't have TV. So how did you circulate who's who today? Who's hot? What group is hot in politics right now? You put their portraits on coins, and you put some writing around the outside of the coin, or maybe even some things on the back of the coin that tells what offices they held or what they were important for. And what you had going here was that Mark Antony had these coins circulating all throughout the Roman Empire. This really scared the Roman Senate, because here was the Queen of Kings. They knew right away that Mark Antony fully intended for he and Cleopatra and their children to govern not only the entire Roman Empire, but all the Egyptian Empire. And this scared them to death. Scared them to death. Now, Octavian did not have a lot of support right after Julius Caesar died. Not a lot of support at all. Number one, his name was Julius Caesar, and he was very young, and he didn't have good health. But something bizarre happened. And you'll never learn this in the history books. I'm going to go back to these two pictures. I'm going to go to this one first. Something bizarre happened. Julius Caesar was murdered, assassinated on March 15th, the Ides of March, 44 BC. Octavian took all the money, and he knew that he had to win the Roman populace. Now, how did you win the Roman populace over? You have to pay him. Right, that's one way. He paid a lot of people money. That's how leaders did it, but there were other ways. Bread and circuses. You take the people and you give them something to distract them and entertain them. If you pay for the party, people remember your name. Or at least you hope they do. So he threw giant parties in the Colosseums. He threw a great series of games. They were called victory games. They were called games that were games in honor. What am I doing? Am I going to knock something over? Oh, I just did. I just sat in my Coke. How wonderful. Thank you, Leonard. Well, anybody know how to get Coke out of silk? I don't know. Anyway, something very unusual happened on July 14th. The middle of July in 44 BC. Octavian, you can recognize his portrait, I'm sure you know now from the family resemblance here. Good old Octavian threw these wondrous games in praise of his dead uncle. He wanted power. So he was trying to get the people to suck up to him. And he did it this way, by accident. On the night the game started, a comet appeared. Suetonius, the historian, writes about it. Pliny writes about it. Even Octavian writes about it in his biography, his autobiography. A comet appeared and was visible at the 11th hour every night in the north for 7 nights in a row, in the northwest.
Sit back, man.
It was a bright comet, and people could see it right over the Colosseum in honor of Julius Caesar. These games are in honor of Julius Caesar. Well, this was 44 BC. The people were so impressed that Octavian got an idea. He spread the rumor that the senators had murdered his uncle, Julius Caesar, and that the gods were so angry that they waited for the celebration in honor of him, of his death, and that during the games they were taking the soul of Julius Caesar into the heavens to join him, have him join with the gods in the sky. And the Roman populace thoroughly believed that that comet of 44 BC was the soul of Julius Caesar going into the heavens, and that the Roman Senate had murdered a divinity, had murdered a god, at least a half-god. Well, we see a coin here, which I call I think is the most famous coin in history. Oh, excuse me. I was trying to focus here. It's a comet coin. Octavian recognized a real opportunity. He went to the statue of his uncle, Julius Caesar, in the temple, the major temple. He had a star affixed to the head of Julius Caesar. And then throughout his reign, every once in a while, when he finally became Caesar Augustus, he had coins minted, and never to let the people forget who he was. He got his ball rolling by saying everyone walked out of the games after 7 nights of games and a comet all the time. They said, if his uncle is Julius Caesar, is a divinity, a god, and Julius Caesar adopted him as his son before he died, then Octavian has to be the son of a god, a divinity himself, or at least a partial divinity. So you can see a comet here. This is a comet. Portrait of a comet. The tail. The hairy comet, or flaming, sometimes they're called flaming comets. And here you see in Latin, Divus, D-I-V-U-S. The I here is a J. Julius, J-U-L-I-U-S. Divine Julius. On the other side, what do you see? A portrait of his adopted son. It was difficult to beat this combination. People were very superstitious. This was no small item. This was about as big an endorsement as you could get. You got an endorsement of a comet? This is the best propaganda. You can't buy this kind of stuff. This comet changed history. He milked this comet for all it was worth. His best buddy, Marcus Agrippa. These are great portraits. They look almost like people you'd see today on the street. His Marcus Agrippa, his buddy, was the greatest general after Julius Caesar. Marcus Agrippa decided the future between Cleopatra and Mark Antony. It looked for a while that Mark Antony and Cleopatra would become the heads of the entire Roman and Egyptian empire. They would join Western thought with Eastern thought, so to speak. It didn't happen because of this man. This man fought the sea battle of Actium with Octavian's forces, with him as the head, Marcus Agrippa. The Battle of Actium was fought, and this is the famous battle where fought at sea, where Cleopatra and Mark Antony rushed back to Egypt on their ship because they're losing the battle at sea. The Battle of Actium decided which way Rome was going to go for all time. This is a wonderful bas-relief of a boat celebrating the Battle of Actium. They have a crocodile here carved on the front in this bas-relief, showing it's a Roman boat, showing that this was one of the boats that was used to conquer the Queen of Egypt, because the crocodile was considered the symbol of Egypt. And of course, Octavian, being very smart, more propaganda, Egypto, that's how you spell Egypt in Latin, Egypto Copti, the capturing of Egypt, the crocodile, Egypt. Who's on the other side? Our friend Octavian. So Octavian used his coinage, used the comet propaganda to really solidify his position as emperor. He was a great emperor, and the first emperor. Remember, Julius Caesar was the dictator of Rome. He was a great one, all right. And people have misused comets ever since. And a lot of people were misusing comets before that. For instance, in 184 BC, Hannibal the Great was told by his soothsayers that a comet was on its way. And they started to see it in the evening sky. And Hannibal was very superstitious about comets. He had been born on the sign of a comet. He was told that this would signify his death. He got so shook up that he actually took poison and died. In 88 BC, I forgot, 88 BC. I'm losing it because I did this stuff many, many years ago for Halley's Comet. We know that that in 79 AD, when Pompeii was about to be blown off the map with Vesuvius, we know that the Roman emperor at that time, whose name was Vespasian, we know that he was a bald fellow, and he was told by his astrologers that the comet that was coming in was signifying his death. And he was very clever. He said he was not superstitious. He said, this comet is not meant for me, it is meant for my enemy, for he is hairy and I am bald. And the next day he dropped dead.
The enemy dropped dead, or Vespasian?
He dropped dead. Vespasian dropped dead. And we have examples all throughout history. In 1227, when Halley's Comet came at this brightest and closest return to the Earth, there was a fellow in France called Charles, and he spent all his youth and all his time debauching, drinking and playing around. And he was such a wild man that they called him, nicely, they called him Charles the Debonair. Well, when this Halley's Comet showed up, the brightest and closest return, it was so bright it could be seen in broad daylight. He was so shook up that he immediately repented. He went on a church building spree because he didn't know if he'd be dead the next day, the next week, the next month. Very superstitious. He built all kinds of churches, gave lots of money to the clergy. He became so pious that he became known as Louis the Pious. Now, in cute story in 1556, there was a king named Charles V. And he got so shook up by a comet that year that he left the throne and he became a monk. Simply because he was scared to death by the comet, because the comet signified the death of kings. Comets got so infused into the whole system, especially with the Roman emperors. For instance, did you ever see I Claudius, the whole I Claudius routine? Well,
yeah.
Claudius married Agrippina. Now, Agrippina was not a nice lady. Agrippina was the mother of Nero. There was a great comet scene when Claudius came in. All of Rome talked as if he were already dead. They really did. Because people really believed that they came in and they went out with comets. Mark Twain believed it in the last century. He said, I came in with Comet Halley, I'll go out with it, and he did. People were superstitious. This really shook Claudius up. He consulted his astrologers, and they said, well, don't worry about it. But he did die when the comet appeared. He did die. Historians think that Agrippina gave him poisoned mushrooms because she wanted her son Nero to be the next emperor. They're pretty sure that he was poisoned, but he thought he was going from the comet. We have a lot of other instances of great world leaders having been done in by comets. Genghis Khan, for instance, slaughtered over 1 million people during the appearance of Halley's Comet. Over 1 million people, because he believed that the comet was on his side, and he used it as an excuse for war. The Seminole Indian War back in the last century, I tracked this out. I discovered some weird facts that the Seminole Indians actually went to war in the last century. The reason they went to war when they did was because of the appearance of Halley's Comet. They chose their war dates because of Halley's Comet. It was lost in the archives in Florida. I dug it up and was absolutely flabbergasted that events this short a time ago were concerned with comets. When Nero became, well, he ruthlessly used comets more than anybody did. When Nero, there was a comet in 60 BC, 60 AD. A great comet in 60 AD that came along, and he was superstitious enough to be frightened, but also not as superstitious as a lot of the other guys were. And he said, consulted his astrologers. He had a huge staff of astrologers. He consulted them, astrologers, astronomers, and asked them what to do. And they said, well, you know that whenever a comet appears like this, it means the end of an empire, that great people will fall. Great people are destined to destruction, to disaster, to die. And he said, is there any way that I can circumvent this comet? And they said, there is a way. And I'm sure they got paid a lot to give them the information. All I have to do is turn on TV after 2 o'clock at night, and you'll see people, dial a psychic, give me a break. Things haven't changed much. He said, can I circumvent this comet? And they said, sure. Important people have to die. So he murdered 500 or 600 of the greatest noblemen in town. Sent their families and their children to far-off islands and starved them or butchered them. He thus fulfilled the prophecy. He said, important people all over Rome have died because of the comet. God spared me. He confiscated their property and used the monies from their properties to build himself his golden palace on top of the hill. Really, and he used the comet for that purpose. Halley's Comet, which came along 6 years later, he escaped that one. Then the great comet of 66, when Jerusalem was destroyed by the Romans, they claimed that that was their right to destroy Jerusalem because the comet had appeared. And that was okay. Go on the warpath. It's all right. What's one man's disaster is someone else's good fortune. Well, this guy really believed in comets. I wish I could read some of the literature about the things about... if you go back to the poetry of Virgil and Homer, go back to Virgil and Horace, it's absolutely amazing. You see references to constellations and stars all over the place. I mean, they ruled their lives by these things. He actually forbid astrology for a time in his reign because he realized that it could be very destructive to himself. Although he used it to the hilt. Here he was as emperor, and here was his buddy, Marcus Agrippa. When Halley's Comet came in 12 BC, this man, who proclaimed himself divine because of the comet of 44 BC, when Halley's Comet came in 12 BC, Agrippa died. Octavian, who was now Caesar Augustus, told the people that the comet came because it foreshadowed the death of the greatest general Rome had ever seen outside of his adopted father, Julius Caesar. And so he had a week-long death ceremony, procession, games, the whole 9 yards, celebrations, and he actually buried Marcus Agrippa in his own tomb. He used the comet for incredible propaganda. We find all this very hard to believe today, but it did happen in our whole civilization. Really, if that comet of 44 BC hadn't happened, Octavian never would have become as popular as he would. The common people believed in him and pushed him, so the senators had to buy his deal over Antony's and Cleopatra's. Antony could not fight that comet. Cleopatra couldn't. Well, today, of course, we know what comets are. They are simply wonderful, icy, stony, rocky mountains that come in from the solar system, out from the depths of the solar system, and visit us every once in a while. And of course, I think that after all the comets in history that have changed history, the Battle of Hastings, so many battles were fought around comets. I think it's amazing that we've got the first close-up pictures of the nucleus of Halley's Comet. These were, taken during the time of Halley's flyby in '86. Here you can see the nucleus. There's the sun over there. These are the jets, the gases coming out from the nucleus. It's shaped kind of like a baked potato. This is the dark portion of the comet, the dark tip not illuminated by the sun. And we've seen a nucleus of a comet. This is the technological feat is just unbelievable. And those are the gassings, the outpourings of gas, or something like 400 tons of water are released into vapor every single minute as this comet approaches the sun. Here we have a comet nucleus of a comet whose tail grows to millions and millions of miles in length, which has repeatedly visited the Earth. We've had records of it since 240 BC. And we were the first people to ever know its true nature, what it really is. It's about 9 miles by 5 miles. There's some debate. Some people say it's 7.5 by 4.5. But anyway, it's roughly the size of Manhattan. And it's been visiting us regularly. As I say, there was a gap in the record, in the Halley Comet record. The oldest written record we have is 240 BC. But the one in 164 BC was missing. Nobody had a recording of it. It was not recorded by the Chinese. It wasn't recorded by anybody. We thought the records may have been lost. We don't know. Certainly Halley should have been recorded in 164 BC. Well, I collect antiquities. I have for years. I collect coins. I collect bronzes. I collect vases. I collect statues. I collect lots of things. And I have a ring that I had made around a coin that was minted 164 BC by Ptolemy VI, who was a great-great-great uncle of Cleopatra VII, the double eagle of Egypt. And I wore this because it was minted in 164 BC, the year that Halley came and nobody recorded it. Well, in 1985, just as Halley was on its way back, somebody went down into the basement of the British Museum. They went through a lot of old clay tablets. And they found this Assyrian tablet. And it was deciphered in the red. It reads, tells all about the appearance of Halley's Comet, even gives the date, the direction it came in from, how bright it was, and how long it appeared. And it's exactly right. So this is, now we do have written records all the way back to 240. The 164 BC gap was finally filled in. Now, if I can have the lights on, please. We'll keep the projector on. I brought some things with me tonight. First of all, I do hope that all of you were able to pick up one of these. I had these shipped from Miami. These are my sponsors, Sky and Telescope, my current sponsors, handout. There are several of these here. Please take one home with you, or two if they're that. And I'm going to raffle, well, I'll have somebody raffle off during your meeting, I guess. I brought along, I don't know, 6, 7, 8 of these. Keep looking up. Bumper stickers. Oh, more than that, maybe 9 or 10. Well, and what else did I bring along? Oh, I brought along some do-it-yourself, 1, 2, 3, 4, 5, 6. Do-it-yourself star wheels. They're star wheels. I think you'll like them. You put them together yourself. So these will be here for you to raffle off during your business meeting or after your business meeting. But I did bring something. I thought I want to read. It's a little late. I want to read you from some of the poetry about the stars and the comets. It's absolutely wonderful at the time when the Battle of Actium and all these things went on. It's absolutely fascinating how these people were really absorbed into this stuff. But I won't do that. I will let you see. Well, I've never done this before with this many coins. I brought these along simply because you're avid astronomers. I brought along some things I thought you might be interested in seeing and touching and holding. I don't know who we're going to have. I'll have to pick 4 people who will. Mike, would you do one? Maybe Tracy, you do one. Help me up here. Tracy, you around? Leonard, maybe you?
What we doing?
Just come on up here so I know where things are.
There's a...
That's it. In order to pay his soldiers, he minted his own coin. It says Caesar on the bottom. It's a real coin from 49 BC. He used this, it's a silver denarius, to pay his soldiers. Has an elephant stepping on a snake, which indicates that he had great power. He was an elephant, could squash a snake. On the back, there are all kinds of religious instruments, which was propaganda to describe one of the positions he held that of great esteem was that of a high priest. These were religious censers and sprinklers, all kinds of stuff. So, Leonard, please be Julius Caesar for tonight. We'll put you over here. People can come up to you to look at that. Okay.
This is for me?
Okay.
How old is this?
In 49 BC.
Oh, my God.
Well, maybe 48 BC. We're not quite sure. Look right here. It's here. I can't. Does it say 49 BC or 48 BC?
Oh, I don't know. A little before
Yes, sir.
my time.
When he said that the die is cast across the Rubicon, was the die for the coins?
No.
Die.
No. I'm wonderful. You remind me of something. Elizabeth, the first, actually said that. He said that the dice is tossed. He meant the dice, that kind of die, the dice. In 1577, Elizabeth I was warned that there was a comet outside her window, which of course there was. And this is a true story. And she was not superstitious. She was a very tough, strong-headed woman. She was told by the astrologers and her people of her court who did not want her to do anything, go to war, do anything drastic, and she made up her own mind about anything. Anyway, they told her that it would be dangerous for her to make any moves and do anything to go to war against the Spanish, etc., 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 because of this comet out there. It was going to be disastrous for her. And the story is that she went to the window, she threw open the drapes, and she said, Lacta es alia, which translated means, in the die is cast, or as I loosely translated years ago, damn the comet, full speed ahead. Okay, Tracy, I'm going to give you the coin. This is called the coin of coins for Egypt. This is 36 BC.
He's older than me.
Yeah. Cleopatra's portrait is on here. She's about 36 years old. Mark Antony is on the back. This is where the portraits are not very good, because they were made by someone who just wasn't a good worker in metal. But this is the one that Antony circulated all over the Roman Empire. It was a silver Roman denarius, minted in Alexandria, which was circulated all over the Roman Empire, that said, Queen of Kings, meaning that Antony had full intention to become the Emperor of Rome with Cleopatra as his queen, and he perhaps even as a king. That's that coin. Okay. Where am I putting these things? Okay. This is, we got to have one more person. Anna, come on. You can be a younger Cleopatra, okay? Okay. This is a portrait when she was 32 years old. This is around 32 or 34, I can't remember which, but this is right around, 38, 39 BC. She looks a lot better here. Really a lot better. That is a nicer portrait of her, much nicer portrait of Cleopatra. And, okay, Mike, now we'll put the two Cleopatras together, the ladies can stay together. The two queens, and come over here. And of course, oh no, you got to stay where you are, Julius. Get back.
Mark Antony.
Right, no, this is, the Mark Antony's on the back of your Cleopatra. This was minted about 19 to 18 BC. And this says Caesar Augustus on it. This is the comet coin. On the back of it, it's even better than the one in the photograph. It says Divus Julius, the divine Julius. There it is. That's the coin that made the Roman emperors divine, and it changed the entire course of history. It commemorates the comet of 44 BC, stamped about 19 or 18 BC after Octavian became Caesar Augustus. He just didn't want anybody to forget that the gods approved him. It says Divine Julius on one side and Caesar Augustus on the other. So all of you want to come up and take a look at Julius Caesar, Cleopatra, Mark Antony, a younger Cleopatra, and the comet that made the emperors divine. Help yourself.
May I see your ring?